Okay. So as for the output scan status scan, what you're trying to do is that scan is done, okay, whereby the stored output values are sent to actuators, okay, like what all has been decided by the program, okay, those stored output values are sent to actuators, okay, and then they will perform that physical function that they are supposed to do, okay, and then the outputs are updated so that we now know that is the current situation, right? For example, if the motor is on or off right now, and other things could be, as I said, if it's an analog device, you could be having some value attached to it, okay, what exact is the value that the device is running in, okay, or the machine is running in, okay. Clear about this PLC scan cycle? Clear. Okay. Okay, you see the advantage of PLC, or let us have a video, okay. Here we'll see a video.
Almost every commercial building.
Is it running? You're able to hear the audio and the video also. Is it visible?
Yes, sir.
Okay.
An industrial facility relies on the automation of their mechanical and electrical systems. This trend is only set to increase, especially as larger, smarter, more complex systems and buildings are constantly under construction. So, how do we control these systems and what devices are used to achieve that? That's what we'll be covering in this video, which is sponsored by Telecontrols. Telecontrols can make the best.
Okay, that was about company basically that manufactures PLC, okay.
Programmable logic controller is basically a small computer that can carry out pre-programmed outputs based on inputs and a set of specific rules. They control systems with minimal and sometimes even zero manual intervention. The operation can be a simple on-off control based on the status of the input, or a more sophisticated response based on calculations, sequence, and logic. Before PLCs, control was carried out via banks of relays. You
see that, as I was saying, that initially in place of CLCs we were using relays. Okay, that's how they look like. Okay, they used to have all these wires in them. Okay, also to be able to connect one relay to the other or to the other device, so there was a lot of wiring involved. Okay. Okay.
Relay controlled dedicated inputs and outputs based on physical wiring. Relays would control other relays to form logic controllers.
You see how that, what is that? You see, based out of the actuation of this, what do you call, magnet, this arm is moving, isn't it? This armature is moving, and because of that you have a contact here. So there's basically some mechanical elements involved, isn't it? So that's what relay used to, that's how relay used to function. Okay, so and that's how those it completes the circuit basically, right? Moving of that armature completes the circuit, and that's how it used to work. Okay.
For example, with a simple AND gate, only when two inputs are energized, this one and this one, does the relay output energize. These inputs could be sensors, or they could be outputs from other relays. To change the operation, the physical wiring had to be changed. So the physical connections had to be altered if a different response was ever required.
You see how those are connected, right? Because as he was mentioning, if you want to implement some functions such as AND function, right, as was discussed here, okay, like when this relay is on, or this armature has moved, okay, this relay is on basically, and this relay does its work, only then will you have an output. Okay, that's about the AND function, this and this, that's what we mean. So lamp only illuminates when relays 1 and 2 are energized. So that's what, so you need to have a connection, right? So similarly, you have connections all the way. If you want to have a complicated task being performed, or if a task requires different relays to function, then you have to have a connection between them. So that was very complicated to do. Okay, that's what we mean by that.
This is an example of an elevator relay bank. And this is the relay bank from an old electrical substation. As you can imagine, these are not going to be easy to change, and finding faults can be difficult and very time consuming. With the invention of solid-state electronics and microchips, the command logic part of the banks of relays could be replaced with software logic, and so PLCs quickly took over. PLCs vary widely on their application, but they all monitor their inputs, then make a decision based on a stored set of rules, and from those, they then output commands to automate a process.
You see, I was talking about those programs, logic-based functions, right? Like here, if switch 1 is complete and switch 2 is complete, then turn on lamp, right? That's what we mean by rules in that ladder logic functions. That's what we mean, that if this is complete, and how do you know that? Based out of the input interface, right? The input interface tells us what is the status of the input. Either switch 1 is on or off, basically open or closed in this case. So if it is open or if it is closed, and this is open or closed, then what to do? Okay, so you have a that program being written, right? So based out of that, the CPU of that PLC will execute the output, what is to be done. Like for example here, then turn on lamp. Okay, that's the output. Is that clear? Or any doubts? No doubts. Okay. You see, I could even call out names. Okay, I have done that in the past, but there's no use if you are not paying, if you do not have any interest in the subject, isn't it? That'll be forceful learning, and that will not be beneficial. So you have to have the interest, isn't it? And if you're not able to understand, please respond. Okay, I'm open to feedback as well. If you do not understand the subject, okay, please feel free to say that. Okay, but the interest has to come from you. Otherwise, just calling out names and asking you random questions, or basically the question that we are of the topic, right, being discussed, but has no meaning if you don't carry the interest. Okay. Okay, we'll continue that.
We often find relays used in combination with PLCs. The relays can directly deal with the automation tasks and communicate with the PLC. This will reduce the amount of programming required on the PLC and also free up storage space.
You see, we can even use relays when we are using PLCs. We can even attach those relays to the PLCs so that what the work that was required, okay, for example, this relay, instead of programming it, we can attach a different relay, okay, so that decreases the computations involved, isn't it? So even though that can be done if at all it is required, so that this PLC is not overburdened, you can attach relays. Even that is an option. Relays are often used in combination with PLCs also, because they reduce PLC programming and save storage memory. Because to be able to store what is to be done by this relay or this relay, have to have some dedicated memory for that, right? So that will be saved.
PLCs are widely used. For example, when you check a bag in at the airport, the bag is given a
You
barcode.
see, a very general example, an example that we can understand, right? Very simple example, not an industrial one as in our manufacturing, but has to do with the luggage, what do you call, luggage handling at the airport, right? You see, this will give you an idea of what the PLC does, okay?
And it enters the conveyor belt. A PLC scans the barcode and, based on a set of rules, decides if the bag is diverted to either the domestic or international route. The next PLC scans the barcode and decides which city the bag needs to be diverted to. The next PLC decides which gate it also needs to be diverted to. And if all of this goes to plan, then the bag will arrive at the correct gate. First,
Clear, right? Very simple example, isn't it?
we have the input modules of field sensors. These are the physical connections between the outside world and the PLC. These can be digital inputs, such as simple on-off switches, bimetallic temperature strips, presence or motion sensors, or even a float switch. These digital inputs can only provide information on whether something is either on or off, and nothing in between.
Isn't it? That's what the simple example that I gave was a switch, on and off. That's all, right? So that's about the digital inputs. Okay, that's one form of input.
For that, we would need an analog input. For example, a simple control knob which ranges from 0 to 100%. This will go through a voltage transformer to give 0 volts at 0% and 10 volts at 100%. The PLC can scale the input to match the sensitivity required for very accurate output control. It could also convert the voltage into current using resistors and Ohm's law. The amount of current, usually measured in milliamps, tells the PLC whether something is performing between on and off. These inputs could be, for example, a thermocouple or a resistance temperature detector. It could be a pressure sensor or perhaps a strain gauge. These voltages or currents are converted into a digital equivalent number that can be understood by the CPU. We will look at that a little later in this video.
Clear, right? If you have an analog input instead of a digital one, you have to know the different values of it. And how do you know that? You convert into a voltage basically, or a current. Okay, depends. Because we can have the conversion, right? We have laws such as Ohm's law. So either currents or voltages. Okay, so that we can know that if the current is this much, then it indicates that the knob is displaying 30 as an input. Okay, that's how we can read the status of the input based out of the current. Okay, that's the conversion that will be used. So either current or voltage. So that's what that is what about the analog inputs. Okay, if it is a digital one, nothing is to be required, right? It's just either on or off. Okay, so either this or that, two things. But in here you have a specific value for analog things, so you have to have some sort of conversion, and there could be even sensitivity. It could be even sensitivity issues. So for the PLC to understand, it either scales it down or scales it up. Okay, magnifies. So if it is too small for the PLC to understand, it will scale it and then understand what is actually the status of the input. That's what we mean by sensitivity. How sensitive it is, so depends on the different PLCs. Okay, these are the different analog inputs, pressure sensors. Okay, these are all value based, right? Not just on off like a digital switch. You have values attached to it. Strain gauge also, how much is a component straining. You attach a strain gauge to a component which is under load. So based on the load, the deformation will change, and based on the deformation, your strain gauge will give you the value in volts or in either voltage or currents. Similar goes for resistance temperature detectors also. That detects the temperature basically, right? It's almost 10:30 now. We'll continue, okay, in the next class, hopefully. No doubts, just an yes or no program. No, the program will specify, okay, what it will read out of a digital input is whether is the device on or off. Okay, is that a question or you're trying to confirm? I'm not sure, because please write a question mark at the end so that I can understand if you are trying to affirm or you're just asking a question. Yes, 336. Was that a question? Okay, then I'll end the meeting. Okay, you can join the next class.